All right, guys, I'm going to try one more example here, my budget version of Khan Academy. This time, for this one, it's the same basic setup, except what you'll notice is this time we have a variable on the other side, okay? It's on the right side of the equation. That's not really going to matter, okay? Because as long as we know which side we want the n or the x, whatever it is, on whatever side we want it on, we can keep it on. So I'm going to call this the variable side of the equation. I just put a little v there to remind myself. I do a little dotted line to remind myself that there are two distinct sides of the equation. So 33 equals negative some number plus 16. Okay, so let's figure out how we can get this negative n all by itself and figure out what n represents. Okay, so the first side here, there's nothing to do yet with this. So I'm going to just rewrite 33 equals negative n plus 16, right? We know we want the n by itself. This 16 is just in the way. It's bugging me. I don't want to add 16 to anything. I want that gone. So the only way to get rid of it is to do the opposite operation. So instead of adding 16, we need to take 16 away. Negative n plus 16 minus 16. Okay, all good? No, not yet, because we have to go back to the first side of the equation. I didn't leave much room here, but I have to take 16 away from this side of the equation. 33 take away 16 equals negative n plus 16 minus 16. I know it's very confusing, okay? But the most important thing is we know that 16 take away 16 will equal 0. That's what we wanted. We wanted to get rid of that from that side of the equation, which leaves us with just negative n. All right. Now I know that seems weird that it's a negative, but that's okay. We'll figure that out as we go. And now we have to do 33 take away 16. Okay, what's 33 take away 16? Well, you can use the algorithm if you want. Just do some work on the side. I have to borrow from this side. 13 take away 6 is 7. 2 take away 1 is 1. So 17. 33 take away 16 is 17. All right. So does that mean I'm done? N equals 17? Not quite. All right, because it's a negative n. I want to know what positive n is. All right, so, I mean, we know now that it's going to be the opposite sign if we just do this. Okay, we're going to divide both sides by negative 1. All right, because it's almost like negative n is the same thing as saying negative 1n. We just don't need the 1 there. But in the previous examples, we divide by whichever number is in front of the n. So the negative 1 is the implied number there. So those cross each other out, and now we're left with positive n. But if we take 17 and divide it by negative 1, it's going to be negative 17. So we are saying that n equals negative 17. The only way to prove this is to check by putting that answer, negative 17, back into the original equation. So 33 equals negative n plus 16. Now I'm going to substitute my answer into here. 33 equals negative 17 plus 16. Very confusing, I know, okay? It's almost like there's a negative 1, okay? We have to pretend. So 33 equals negative 1 times negative 17. Negative 1 times negative 17. That's going to be positive 17, right? Because a negative times a negative becomes a positive. All right? Now the 1, again, the 1 is implied. It's not actually there, but it doesn't matter. If we put it in, it's going to make it easier to do the calculations. Positive 17 plus positive 16, sorry, that's a plus sign, not a 4, is 17 plus 16, 33. Absolutely it is. 33 equals 33. That is your answer. Boom. Got it.